Hey everyone, welcome to another video of hok'stutoring. Today we'll be going through a tutorial video on question 9 of chapter 2F. So if you watched the topic video last week, this is on your simultaneous equations, and specifically we're going to be talking through the 3 different types of simultaneous equations that you can get. So one where the pair of equations would give you a unique solution as its intersection. Second, will give you an infinite set of solutions, and third will give you no solution at all. So just to draw this diagram again, unique solution, you have two lines that intersect, cross each other. For infinite set of solutions, you have two lines which are the same lines, and therefore they just intersect at every single point. And then for no solution, you have two lines which are parallel to one another, and therefore they never intersect. So just to go through this quickly for a unique solution, so I'm going to do this question by categorizing it into 3 separate categories. Infinite, and then we're going to have no solution right here. Okay, so parallel. So let's go through the criteria for two equations or two lines to be unique. The criteria for that is m1 cannot be equals to m2. So that means the gradient cannot be equal to each other, because if it's equal to each other, then you get one of these two scenarios, which is when m1 is equals to m2, m1 equals to m2. Now, the C1 and C2, so again, an equation of a line can be written in general form as y equals to mx plus c. So when I'm referring to m, I mean the gradient, and when I'm referring to c, I mean the y-intercept. So the c value in this case does not matter for a unique solution because for unique solution, the only thing that matters is your gradient, okay? As long as they're not parallel, then you will always get an intersection across somewhere. For infinitely many solution, you need to have the same line, and for your two lines to be exactly the same, well, that means your c values have to also be the same, and no solution is just the opposite. C values cannot be the same, or else they'll be the same line, right? So that's it. We've set the criteria for these 3, and we can now start solving the question. Question 9, let's have a read. Find the values of b and c for which the equations x plus 5y equals to 4. That's equation number 1. And then equation number 2 is 2x plus by equals to c. And b and c here are constants, so we're trying to solve for them so that they give us part A, a unique solution, part B, infinite solution, and C, no solution at all. So without further ado, guys, let's get into the question. Let's go. Part A, finding a unique solution. Well, if you want to use this criteria, guys, you need to make sure your equations, equation 1 and 2 here, are in this format, so that's easy to see. So equation number 1 is x plus 5y equals to 4, and I'm going to rearrange it in a way so that it's, in this format right here. This is very important. You need to arrange into this format so it's easy for you to determine what the m, the gradient, and what the y-intercept is, okay? So 5y equals to negative x plus 4, and then y equals to negative 1 over 5x plus 4 over 5. So there we go. Now this is in our mx plus c format, and we do the same with equation number 2, which is, 2x plus by equals to c, and by is equals to negative 2x plus c. Therefore y is negative 2b x plus c over b. And guys, once you have it in this format, it's very easy. If you want to find unique solution, you just need to make sure that your m1, which is negative 1 on 5, is not the same as your m2, which is negative 2 over b. Well, your negative cancels each other out, and you can then proceed to solve for b. B, you can shift it up here, so you get b over 5 is not the same as 2, and therefore b is not the same as 10. And that's pretty much it, because we don't really care what your c is, right? As long as you have your intercept as not equal to each other, then in this case, when b is not equals to 10, then these two equations right here, they will cross paths just like that, because they don't have the same gradient, right? So that's what we did. So when b is not equal to 10, then they intercept. You don't have to care about c, so c can pretty much be everything, because C in this case is you're comparing 4 over 5 to C over B. We don't really care what the y-intercept is, so you don't have to worry too much about that. Okay, guys, so that's the answer to question A, and we can now look into question B, which is for an infinite set of solution. And we can leverage off what we did in part A to help us solve for this. So we know that the equation m1 equals m2 is very similar to the equation m1 not equals to m2, right? All I needed to do is just essentially use this gradient, negative 1 over 5, use the other gradient, negative 2 over b, but instead of making them not equal to each other, we make them equals to each other. So you get this equation right here, and all you need to do is just solve for b again, and in this case, b is equals to 10. Okay, that's pretty much it. We solved that already down here. So now that you have b equals to 10, we need to also, unlike the first part, we need to consider the y-intercept as well. So c1 must equal c2. In this case, what do we know about c1? c1 is 4 over 5, and c2 is c over b. We know that b is equals to 10, so therefore c is equals to, well, 4 times by 10, which is 40, 40 divided by 5, which is 8. So when b equals to 10 and c equals to 8, you have an infinitely many solutions, or set of infinite solutions. Okay, so that's how you solve for part B. And then for part C, guys, no solution, very simple. We know that when b equals to 10, m1 is equals to m2, and we know that when c is equals to 8, then your c1, c2, your y-intercepts for these two equations right here are the same, right? So in this case, if you don't want c1 and c2 to be the same, then you can just say, hey, my c value right here, see, comparing these two, should not be equals to 8. So in that case, you will get no solution at all. Okay, so guys, I hope this makes sense. Question 9. If you did find the video useful, please leave a like, would really appreciate it, and make sure you subscribe to hok'stutoring YouTube channel if you want more of these contents. Alright, so that's the conclusion of chapter 2F question 9. I'll see you in the next video. Enjoy!